The average ancient human did not die at 30. That number is real enough to appear in textbooks, documentaries, and conversations where someone wants to prove that modern medicine has made 40 the new immortality. But it does not mean a healthy 30-year-old regularly reached the biological expiration date, looked around the camp, and quietly stopped working. It means babies died, a great many of them. Imagine 10 people born in the same ancient community. Several die in infancy or childhood. One dies from an infected cut at 23. Another survives childbirth several times and reaches 50. Two others live into their 60s. One becomes the irritating 70-year-old who remembers every route, every argument, and exactly how much better people made tools before the younger generation became careless. Average all those deaths together, and the answer may land somewhere near 30. No individual had to die at the average. The number is mathematically correct and emotionally misleading. So at what age did most ancient humans actually die? The uncomfortable answer is that death gathered at both ends of life. The most dangerous years were often the first ones. Survive childhood, and the odds improved dramatically. Reach adulthood and dying in your 30s was possible, but it was not the normal biological schedule people imagine. Among well-studied hunter-gatherer populations, the most common age of adult death has often fallen around the late 60s or early 70s. Ancient life was not short because everyone became old at 30. It was short because becoming old was never guaranteed. Let's go through it properly. First, we need to separate three numbers that are constantly forced to wear the same name. Life expectancy at birth is the average number of years a newborn would live if the mortality conditions of that population remained the same. Lifespan is how long an individual actually lives, or sometimes the maximum age members of a species can reach. And the modal age at death is the age at which deaths are most concentrated, the peak in the distribution. These numbers answer different questions. If a population has severe infant mortality, life expectancy at birth can be low even when adults regularly reach their 60s. If almost everyone survives childhood but dies around 75, the average and the mode move much closer together. Modern societies have made death more concentrated at older ages. Ancient societies spread it across the entire life course with a brutal amount of it near the beginning. The average is not lying. It simply has terrible bedside manner. Take an extreme example. Two siblings are born. One dies at age 2. The other reaches 70. Their average age at death is 36. Neither sibling dies at 36. Now expand that across a whole community. Add stillbirths, newborn deaths, childhood infections, accidents, young adults lost to violence or childbirth, and older adults reaching 60 or 70. The final average can sit in the low 30s, while describing almost nobody's actual experience. Research comparing several small-scale hunter-gatherer and horticultural populations has placed average life expectancy at birth broadly around the low 30s with considerable variation. That is the source of the famous number. The same research found something very different once childhood mortality was separated from adult mortality. Roughly 60% of newborns survived to age 15 across the populations examined, and the modal age of adult death was about 72. Varying approximately from the high 60s to the high 70s. That does not prove every Paleolithic population followed the identical curve. Modern hunter-gatherers are not prehistoric fossils wearing contemporary clothing. They live in modern political systems and countermarkets, medicines, state violence, introduced disease, land loss, and environmental disruption. Ancient groups lived in different climates with different technologies, pathogens, predators, and population densities. But the comparison destroys the cartoon. Human bodies did not evolve to collapse at 30. Our species carries a capacity for long adult life that predates hospitals, antibiotics, and retirement advertisements featuring extremely clean bicycles. The real filter came first. Birth itself was dangerous. Human childbirth is unusually difficult because babies have large heads and the fetal body must pass through a tightly constrained curved birth canal. The old claim that this resulted simply from a trade-off between brain size and efficient walking has been revised and debated. Human pelvic anatomy is affected by several evolutionary and biological pressures including support of the pelvic floor, fetal growth, maternal metabolism, body form, and locomotion. The practical fact remains unchanged. Giving birth without surgery, blood transfusion, antibiotics, fetal monitoring, or emergency transport can become lethal very quickly. A baby can be positioned badly. Labor can become obstructed. The mother can hemorrhage. The placenta can fail to separate normally. Tissue can tear. Infection can develop after delivery. The child can be deprived of oxygen or born too early to regulate temperature and feed effectively. Ancient people had skilled birth attendants, practical knowledge, supportive relatives, positioning techniques, and treatments developed through experience. They were not simply surprised every time a baby appeared. They also lacked reliable ways to solve several emergencies that modern medicine now treats routinely. A birth could end with 2 deaths before either person had properly entered the demographic record. Then came the first month. Newborns have immature immune systems, limited energy reserves, and very little ability to compensate when something goes wrong. A mild infection in an adult can become overwhelming in a newborn. Diarrhea removes water and electrolytes from a body that contains almost no spare capacity. Difficulty breastfeeding can become malnutrition and dehydration. Cold nights are more dangerous when a small body loses heat rapidly. Even naming an infant may have carried the emotional weight of uncertainty in some societies. Though customs varied enormously, the child was loved, the future was not promised. Infancy remained dangerous after the newborn period. Respiratory infections, gastrointestinal disease, contaminated water, parasites, fever, accidents, burns, animal bites, and periods of poor nutrition could kill children who would now be treated with fluids, antibiotics, oxygen, surgery, or several days of observation under fluorescent lights. Weaning created another vulnerable transition. Breast milk offers nutrition and immune protection. As children begin eating more shared food and drinking water, they encounter pathogens through containers, hands, soil, animals, and other people. At the same time, a new pregnancy or food shortage may reduce the amount of milk available. The child becomes more mobile precisely when the environment becomes more accessible. Fire, water, cliffs, snakes, tools, objects small enough to swallow. Human toddlers have spent the entire history of the species searching for fresh ways to make supervision feel inadequate. This is why the mortality curve was often U-shaped. Risk was high at the beginning, declined through later childhood and early adulthood, then rose again as aging weakened the body. The middle was not safe, but it was safer. Once a person reached adolescence, their expected future changed. Across the hunter-gatherer populations used in major comparative studies, a 15-year-old could expect on average to live into roughly the early or middle 50s. That still sounds young compared with modern wealthy countries, but remember that this is an average containing adults killed at 20, 30, and 40 alongside those reaching 70 or beyond. The adult mode tells the other half of the story around 72. Not the average age of every adult, not a promise. The age around which adult deaths became most concentrated after the early hazards had been survived. That number is close enough to modern ideas of old age to feel almost offensive after years of being told everyone in prehistory died before developing a strong opinion about teenagers. People in their 60s existed. Some reached their 70s. A smaller number likely reached their 80s. Old age was uncommon compared with today, but it was not supernatural. The human body was already capable of it. This long adult life distinguishes us from other great apes. Wild chimpanzees experience high mortality across adulthood and rarely reach the ages humans can achieve, even without modern medicine. Human survival appears to have been reshaped by food sharing, cooperation, skill accumulation, childcare, and the value older people could continue providing after their physical peak. That value matters because aging is not only decline. A 55-year-old hunter may run more slowly than a 25-year-old. They may also know where animals move during a rare drought, how to read weather, which neighboring group can be approached safely, and what happened the last time someone ate the attractive red plant near the river. The younger person has stronger legs. The older person remembers the funeral. Knowledge can make age productive long after speed decreases. Older adults could gather food, prepare materials, make tools, care for children, teach, negotiate, heal, tell stories, and preserve information connecting several generations. Grandmothers, in particular, have become central to theories about human longevity because they can support grandchildren and daughters after their own reproduction has ended. Although no single grandmother hypothesis explains every feature of human lifespan. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube, what they feared, how they communicated, what hunted them, and much more. Plus, an exclusive PDF guide included. Link in the description. See you inside. Men also continued contributing through food production, knowledge, protection, and social networks. The broader point is simpler. A human group containing older adults has access to memories no child can possess and no written record can replace. Long life became useful. Natural selection had a reason to preserve it. But if old people existed, why do prehistoric skeletons so often seem young? Because skeletons are difficult witnesses. They do not arrive with birth certificates. Archaeologists and biological anthropologists estimate age at death using features such as dental development, tooth wear, the pubic symphysis, the ends of ribs, changes in the pelvis, joint degeneration, and microscopic bone structure. These indicators work differently across ages and populations. Children are comparatively easier to age because teeth erupt and bones develop through a more predictable sequence. Adults are harder. Once growth stops, age must be estimated from gradual degeneration. Two people of the same chronological age can show very different wear depending on genetics, activity, nutrition, disease, pregnancy, injury, and environment. A 40-year-old body exposed to intense labor may look older in one joint and younger in another. After roughly 50 or 60, traditional methods often become especially imprecise. Older adults can be compressed into broad categories, such as 45+, which is demographically equivalent to filing everyone from middle-aged parent to extremely elderly grandparent inside a folder labeled later. Early skeletal studies also tended to undercount older adults because reference samples and methods were biased toward younger age structures. Newer approaches have recovered more older individuals from some cemeteries, changing populations that once looked as though adulthood ended suspiciously early. The bones were old, the method was young. Preservation creates another filter. Infant bones are small and fragile. They decay easily, are damaged during excavation, or may be buried in places archaeologists never find. Some societies buried babies differently from adults. Others exposed bodies, cremated them, placed them in trees, caves, water, houses, or locations where preservation was poor. Adults can disappear too. Mobile hunter-gatherers did not place every person inside a formal cemetery. People died during travel, hunting, conflict, or seasonal movement. Scavengers disturbed remains. Soil chemistry dissolved bone. Rivers moved it. Later, people reused the site. The archaeological population is not the living population. It is the fraction of the dead who entered preservable conditions, remained there, were discovered, excavated, identified, published, and assigned an age. That is an extremely selective afterlife. Population growth can distort cemetery age profiles as well. A rapidly growing population contains many young people, so even ordinary mortality can produce more young skeletons than old ones. A stable or shrinking population produces a different distribution. You cannot read a cemetery like a modern spreadsheet without modeling births, deaths, migration, and the customs deciding who entered the cemetery. This is why researchers approach deep prehistoric lifespan with caution. Modern forager data offer detailed mortality curves but are not direct copies of the past. Skeletons come from the past but are incomplete and difficult to age. Each source corrects the weaknesses of the other without eliminating them. One influential study examined ratios of older to younger adults in fossil dental samples and argued that older adults became much more common during the Upper Paleolithic. The results suggested a major increase in survivorship late in human evolution, possibly creating a feedback loop. More older adults preserved knowledge. Stronger cultural transmission improved survival, and better survival produced still more older adults. The interpretation is important. It is not the final word. Fossil samples are small. Dating and classification matter. And older in dental studies does not always mean 70-year-old. Often it means surviving substantially beyond the age when the third mer finished developing. A relative measure necessary because exact ages are unavailable. The study shows change in adult survivorship. It does not provide a prehistoric birthday cake with 70 candles. Still, individual fossils confirm that long adult life existed deep in the past. Neanderthals and earlier humans survived serious injuries, tooth loss, joint degeneration, and chronic conditions long enough for bones to heal and bodies to adapt. Some could not have continued without support. An older person missing teeth may need softer food. A person with a damaged limb may require others to share food or modify travel. Survival leaves evidence of biology. Extended survival leaves evidence of relationships. So what killed adults before modern medicine? Usually not old age written neatly as one cause. Infectious disease was probably among the largest categories. A cut from stone, tooth, thorn, animal horn, or broken bone could introduce bacteria. Without antibiotics, infection might spread through tissue or enter the bloodstream. A dental abscess could become systemic. Pneumonia could overwhelm the lungs. Gastrointestinal illness could dehydrate an adult already weakened by food shortage. Comparisons with several recent subsistence-level hunter-gatherer and horticultural populations found infection, or broadly categorized illness, responsible for the largest share of recorded deaths. Although the exact pattern cannot simply be projected onto every prehistoric community, ancient populations were smaller and more mobile than later cities, which limited some crowd diseases requiring dense chains of transmission. Measles and similar infections thrive in large connected populations and likely became more important after settlements and agriculture expanded. That did not make forager life disease-free. Zoonotic infections, parasites, wound infections, respiratory illness, and pathogens capable of persisting in small populations remained. Illness did not need an empire. It needed one vulnerable body. Accidents formed another category. Hunting large animals can produce blunt trauma, punctures, falls, and crushing injuries. Gathering honey can involve heights. Fishing and water travel create drowning risks. Fire burns, stone flakes cut deeply. Carrying heavy loads damages joints and increases the consequences of one bad step. A broken leg is not automatically fatal. A broken leg far from camp during food shortage with no way to stabilize the bone can become fatal through blood loss, shock, infection, immobility, or the group's inability to remain in one place. Violence also mattered. The rate varied enormously among societies and periods. Some communities experienced little lethal conflict for long stretches. Others suffered raids, feuds, homicide, warfare, and competition over resources. Archaeological remains preserve projectile injuries, skull fractures, defensive wounds, and occasional massacres. Ancient humans were not permanently peaceful. They were not permanently at war either. The past contains enough evidence to disappoint both fantasies. For women, pregnancy and birth added repeated exposure to risk. Maternal mortality in any single birth may not need to be enormous for the lifetime danger to accumulate across several pregnancies. Hemorrhage, obstructed labor, infection, and complications can kill healthy young women with little warning. This can make female mortality appear elevated during reproductive ages in some populations. Although patterns vary, and skeletal sex estimation introduces its own uncertainty, men may face higher mortality from violence, dangerous hunting, or risk-taking. In other contexts, neither pattern creates one universal ancient age of death. Sex, status, environment, climate, nutrition, group size, mobility, and pure luck changed the curve. Then farming altered the risks. Agriculture is often imagined as the moment life became safer because food was finally produced deliberately. In many early farming populations, health initially worsened. Settled communities concentrated waste, people and animals. Pathogens gained reliable transmission routes. Diets often narrowed around a few stable crops. Crop failure could affect an entire settlement. Dental decay increased in many regions. Repetitive labor left skeletal stress. Property and stored food created new forms of inequality and conflict. Farmers could support larger populations. Individual bodies did not necessarily enjoy the arrangement. This is an important distinction. A successful population can grow while many members live with worse health. Evolution and civilization grade group numbers more enthusiastically than personal comfort. Later cities intensified crowding and epidemics. Historical life expectancy at birth remained low in many pre-Auden states, sometimes comparable to forager estimates. Even though the causes and social structures differed, wealthy elites might access more food and care while poor laborers faced malnutrition, disease, dangerous work, and warfare. There has never been one ancient human lifespan. An Upper Paleolithic forager, Neolithic farmer, Roman urban laborer, Egyptian official, and nomadic herder inhabited different mortality systems. The famous 30-year number flattens all of them into one person who apparently reached 31 only through administrative error. What would old age actually look like? Not exactly like modern old age. A person of 50 could possess heavily worn teeth, arthritic joints, healed fractures, and years of physical strain. Smoke exposure from hearths could affect lungs and eyes. Parasites and repeated infections could leave lasting damage. Hearing or vision loss would be difficult to correct. Chronological age and physical condition did not move together neatly. A healthy 60-year-old with strong social support might remain highly active. A 35-year-old carrying injuries, chronic infection, and severe dental loss could appear much older. Modern medicine has not merely added years. It has changed what many ages feel like. Antibiotics prevent a wound at 20 from becoming the end of the story. Surgery restores joints. Glasses return vision. Dentistry preserves eating. Vaccines remove diseases before they can leave permanent damage. Blood pressure treatment prevents events that once arrived without warning. Ancient adults could reach old age. They usually reached it carrying more history in the body. And yet, they reached it. That matters. Because a society containing elders thinks differently from one in which no generation survives long enough to know grandchildren. Older adults connect events separated by decades. They can compare droughts, migrations, animal movements, alliances, technologies, and mistakes. They make culture less dependent on rediscovery. An elder is a biological archive that can answer questions. Writing performs a similar function later, but it does not gather food, watch children, correct technique, or notice that the clouds resemble the year the river disappeared. The survival of older adults may have helped make human culture more cumulative, the ability to preserve an innovation and improve it rather than repeatedly beginning from nothing. Longevity did not arrive after civilization. Civilization was partly built by a species already capable of longevity. So, at what age did most ancient humans die? If you mean life expectancy at birth, a rough figure near 30 is reasonable for several foraging populations and many later pre-Auden societies, though the exact number varied. If you mean the most dangerous age, it was often infancy and early childhood. If you mean how long people lived after surviving childhood, many reached their 50s or 60s, and some reached their 70s or beyond. If you mean the most common age of adult death, evidence from well-studied hunter-gatherer populations points toward roughly the late 60s to early 70s. And if you mean every ancient human across hundreds of thousands of years, the only honest answer is that no single number can carry that much history. The mortality curve looked less like a wall at 30 and more like a valley. Death was high at the entrance. It fell as children became stronger. Then it rose again as injury, infection, accumulated damage, and aging narrowed the body's ability to recover. Modern life has not invented old people. It has allowed far more people to become them. That is the real transformation. Ancient humans did not usually die because they reached 30. They died because something happened at 3, 23, 47, or 70. The tragedy was not that old age did not exist. Subscribe to Sleep Code.